Okay, yes, Gatika. Thank you, Gatika. So, so ideal gases means that gas that obeys PV over T equals to constant, and now where P is pressure, V is volume, and T is thermodynamic temperature. Okay, so that's what you're gonna write. Gonna get 2 marks. Then it says the mean squared speed of the fixed mass of an ideal gas at 32 degrees is this much. The gas is heated at constant volume to this. Determine the rise in Kelvin. Now, just remember, I just want to tell you, if you find the change in temperature, this is a very important thing. Directly, like you do 80 degree minus 32 degree, and that would be, I think, 48, right? So answer would be 48 kelvins. Now there's a reason behind it. The reason behind this is that when you're finding the change, even if you try to convert it into kelvins, like you do, let me see. If you say it's 80, sorry, 273 plus 80, it's gonna be 353 and minus 273 plus 32, it's going to be 305. Ultimately, 353 minus 305, it's just gonna give you the same answer in Kelvin because the change would be the same. So you don't have to do an extra step. Is that clear, everyone? Hmm. Okay. Now, wait a second. I see. All right. Okay. No. So it says the RMS speed of atoms at 80 degrees. Okay. Now the issue with this is that you got this one. You have the formula as PV equals to 1 by 3 NMC square, right? So this is the formula. The issue is that the temperature. Okay. Yeah. Yeah, okay. Wait. That would be a lot of issue. Now, I just want to tell you that this and temperature needs, there's a derivation behind it that I need to do. I want to do it later, but I think we should do it right now, and we can, do it as a homework later. So you have this formula, and you also know that PV equals to NKT. You guys agree?
Yes, sir.
Right? And you can basically put PV
And NKT is
equals
equal to 1 by 3
NKT equals to 1
NMC
by
square.
3 NMC square. So if you realize this, N, K, N, M, they are all constant. Even this is constant. So T is directly proportional to C squared, which means temperature 1 over temperature 2 can be written as C1 whole square over C2 whole square. And this is just a way of basically doing like you can do a comparison question like this. So the first temperature in Kelvin was 353 at 80 degrees, and at 30 degrees it was 305. At that time, the speed was 1.9 times 10 raised to the 6. We want to find this C1 squared, and we have 1.9 times 10 raised to the power 6. 1.9 times 10 raised to the power 6, and you got to take the whole square. Can you please find the C of this C1? RMS speed, please. This is just a small derivation where you can, relate them together. Okay.
2.0 times 10 raised to 6.
Okay. Sorry.
2.0 times 10 raised to power 6.
Okay. 2.0 times 10 raised to the power 6 would be the answer. Is that clear, everyone? All right. Okay. For some reason, Google has just said that you can basically, they have recovered my files. But I'm not sure about that. So I'm gonna check. I think it's recovered.
Sir, I'm
Yay!
getting 2.2.
You're getting 2.2. Gatika, what is this? Okay, Google has recovered my files, so you can now access everything again. Wow, amazing. Okay, so
You're welcome, sir.
2.2. Thank you so much, Mokshit. It was quick and easy. All right, 2.2 times 10 raised per 6. Can you please check the
So
answer?
it's 2.0.
Can you please check the answer? Stop fighting.
Oh no, I got 2.2.
Go on. Check it, please.
Sir, but unfortunately, I think you have to restore your settings of the Google Drive.
Okay, you guys can't access things anymore?
Yes, we need access.
So none of the answer is correct.
Why? What is one?
Answer is 1480.
Why?
I think he's used
Why?
Why
T1
did
and
we
C1
square
as
it?
the value.
Sorry?
Why did you square 1.9 into 10 raised to 6?
Why do we have to square it?
Why
We have
did you square it?
Because in the formula there's a square. That's why. Oh, have they given RMS?
It was already RMS, right?
No, it was mean square. It was already C. Why? Why would that be? That's not fair with us.
So when I don't put the square, I get 1480.
Did you take under root at the end?
Yeah.
Did you? Are you sure about that?
Yes.
Because okay. Why? Why?
So
This
you
is
can
not
check
fair.
it.
Let me check. Okay, so 353 divided by 305. Okay, and it means that value is there has to be some issue. Why would it? There was a C square already, NKT, and we did
Sir, won't we do
one.
like cross multiplication?
Yes, we are doing that.
So I am getting 2.0 into 10 to the power 6.
Yes, and then you have to take a square under root of this. Sorry, 6, right? And then you take an under root of the answer. Yeah, this is the answer. It means, oh, okay. It means this value
Sure, but
is
you didn't square
basically,
it though.
yeah, I did square because this value they've already given as this one here. We don't have to square, that's fine. It's not root mean, this is mean square speed. So they already gave C2 square, so we don't have to, put a square there, that's fine. All right. So what was the answer then? 1, 4, and
80.
8, 0. Why not 8, 2 or 8, 3?
Significant figures.
Yeah, because that would be wrong significant figures. So do not write 1, 4, 8, 3. Okay, do not write that. Anyway, any questions, please? Everybody understands this? Okay. All right, now let's go forward to the next one. Here it says it is assumed that all molecules moving with speed v and the pressure p exerted by walls, where m is mass of one molecule. Explain the reason by which the expression modified to this formula. Explain the reasoning by which this expression is modified to give this formula. Okay, so you just need to write that basically this is like all molecules are moving with speed v, right? But velocity is a vector quantity, right? Hence, we take the mean square speed of the speeds of all particles. Okay, that's why we do that. Then in the next one says the density of the ideal gas is 1.2 at a pressure of this and the temperature is 27. Calculate the RMS. Now, this is something that I wanted to discuss with you people a bit. Okay. Now, if you look at the formula, right? So it is PV is equal to 1 by 3 NMC square, right? You guys agree? Now, if mass of one molecule is equal to m, then the total mass has to be number of molecules times the mass of one molecule. Do you guys agree? Okay, everyone. Now, if I write P here and I divide NMC square with V, can I also write it as 1 by 3 NM over V and C square, please? Would you mind?
No, sir.
Okay. What do you think is this expression right here?
Density.
There's density.
Yes, because it is basically total mass over total volume, right? Now we get an expression where pressure is equal to 1 by 3 density of C squared. We got the pressure, which is 1.0 times 10 raised to 5. 1 by 3 density is 1.2. And now we want to find the RMS speed. So can you find C, please? So this formula that you see right here is one of those formulas which can help you find the densities as well with respect to that. Yes, please. What is the answer?
meter per second.
500 meters per second. All right. Arsalan, Ahmed, Abdul Moiz, Juwaria, Mokshid, Munib, Saman, Tanjim, Gatika, Aman. Do
Yes,
you
sir,
guys?
understood.
All right. Very good.
Yes, sir.
Very good.
Yes, sir.
Huh? Second, please. This is the guy. Oh, Okay, this I said as a homework because this was the same derivation as we did earlier. We're gonna go forward. Now, here we're gonna basically, this is a very important part, and this derivation is the most common derivation that's gonna come in your exam. First of all, in this, it says a sealed container of fixed volume V contains n molecules, each molecule m of an ideal gas pressure P. State an expression in terms of V and P and the Boltzmann constant K for the thermodynamic temperature T of the gas. Okay, so we want V and P and okay, and the Boltzmann constant, thermodynamic temperature of the gas, right? So the thing is, this is n number of molecules. We want to do PV equals to NKT. All right, so this would be our expression that they want. We already know this, so it's not a big deal. But then you have to basically do this one, and that's a very, very important thing. First of all, I would like to tell you what the steps that we are going to take. So you put a star and start looking at it. So the thing is that PV is equal to 1 by 3 nmc square. And we have learned previously that kinetic energy is given by half kinetic energy of a molecule, okay, of a molecule is given by half mass of molecule and the mean square speed. Is that clear, everyone? This is same as half mv square, okay? Fahad, late. Okay, now what you're gonna do is you are gonna put this expression right here into this one. So we're gonna do 1 by 3 nm c square equals to nkt. You guys have any issues with that? Huh? Okay. Then if I basically multiply 3 equals to 3 nkt. Can I do that? This is step 1. Step 2. Now in step 3, what I'm going to do is I'm going to multiply both sides with a half. So if I multiply half on this side and half on this side, would it matter? Both sides have n, so you can cancel n out. So you're going to get an expression which states half m c square equals to 3 by 2 kt. And if you look at the expression right here, this expression is the same as kinetic energy expression right here. Okay, so then we can say that now kinetic energy is equal to 3 by 2 kt, and that's for only one molecule. If so, this is the whole derivation that you basically needed to do. Okay, but in any case, if let's suppose this comes as the whole gas, right? So then what I want you to remember is for all particles means whole gas, the equation is going to be that kinetic energy is going to be 3 by 2 nkt, because now we are also multiplying the number of particles with this kinetic energy. Any questions, please let me know. Please look at it. Abdul Mois, Ahmed, Aman, Arsalan, you guys are clear about it?
Yes, sir.
Yes, sir.
Bahar, Gatika, Area, Mokshit.
Yes, sir, understood.
Yes, sir.
Okay. Juvaria, why aren't you speaking today? Munib, Suman, Tanjim, you are also okay with this?
Yes, sir.
Okay.
Yes, sir.
I think Javelio's mic is not working. All right. Then the next thing is explain why the internal energy of the gas is equal to the total kinetic energy of the molecules. Right. Okay. This question we're going to do later because this is from thermodynamics. So we can skip it right now. So don't worry about that. Right. But we'll come back to this, or you can solve it later on your own. Because I have done this derivation already, so I'm going to give you this derivation as homework. So you go back, you check it, how I've done this, and you will be able to do it. This is very simple. Will you guys be able to do this?
Yes, sir.
Say yes or no.
Yes,
Okay,
sir.
that's good. That's good. Very good. Now I'm going to go to the next one. Then this is basically the same derivation. This time they've given it for 3 marks. Every time they will give you for, I don't know why they do this, but obviously this will be your homework as well. You can do this derivation on your own now. Okay, but for this one, I'm gonna continue doing the question. हाँ
बाहर पार्क
या कुछ शर्म क्यों आपको?
मुझे डर था कि अंदर लाग ना जाए इस वजह से किया पाया
अच्छा. Okay. A cylinder contains 17 grams of oxygen at a temperature of 12 grams 12 centigrade. The mass of 1 mole of oxygen is 32. So, okay, oxygen, mass of 1 mole is oxygen. Okay. It may be assumed that the oxygen behaves as an ideal gas. Calculate for the mean kinetic energy of a molecule, right? Now, the issue is that we want to find the mean kinetic energy. Kinetic energy is given by 3 by 2 kT for just one molecule, right? So we already have the temperature and the Boltzmann constant. Okay, so let's put it here. Boltzmann constant is 1.38 times 10 raised to minus 23. And the temperature, we got to change this. So 273 plus 12. Can you please do that? What that might be? Yes, please hurry up.
5.9 times 10 raised to minus 21.
1.9 times 10 raised to power
5.9.
21.
Sir, 5.9.
Okay. 5.9. Okay, 10 raised to power negative 21 joules. Okay, then you got to find the number of molecules. Now, the issue with this is that we have like 17 grams, right? So if 1 mole is equal to 32 grams, then I think 17 grams will have how many moles? Can you please cross multiply and check? Okay, number of moles, please.
0.53.
0.53 mole. Okay, then number of moles is equal to N over Na. So to find N, we got to multiply these moles with 6.02 times 10 raised to power 23. That's Avogadro's constant. And the answer is
So 3.2 times 10 power 23.
3.2 times 10 power 23 number. Okay, that's cool. All right, who did not get it, please let me know. This chapter is easy, right? I think. All right. Done. Should I go forward then?
Yes, sir.
Okay. And okay, so this is the question related to the same equation that I asked you to derive. So what is meant by ideal gas? This we have already done, so you can do it as homework, but I'm going to do This one, so symbol of C square. Symbol of C square is basically called
Root mean square.
no mean square speed. In case of root, it would be just C. Okay.
Oh, so mean square speed. Okay.
Yeah. So it's
So
mean
what
square.
is root mean square speed?
When you take under root of this, so that would be
Oh, okay.
then it would be root, because then basically it's like the second step. All right. Then a cylinder contains a fixed mass of gas 120. The gas is a volume of this and pressure of 2.4 times 10 raised to 5. And assuming the gas acts like an ideal gas, show that the number of atoms of gas in cylinder is this. So that's pretty easy. Which formula should we
PV
use?
is equal to NKT.
Yeah, PV equals to NKT. Pressure is 2.4 times 10 raised to 5. Volume is 6.8 times 10 raised to minus 3. Thanks to them, they have just given us the SI units. And K is 1.38 times 10 raised to minus 23. And the temperature is 120. So 273 plus 120. Do not forget that. And what you get, I think you should get the same number, right? Now, this question is very, very important. That's why I want to do this. I'll just show you why. Why I think this is important. Yes, please.
We got exactly
3.0
the
times
answer.
10 raised to 23.
Oh, Javeria is alive now. I think I was like worried for a moment.
No,
All right,
I'm
that
here.
is okay. That's cool. Okay, so we got the answer. That's cool. And then this question I wanted to do, because this is a different one. It says each atom of the gas is assumed to be a sphere of radius this one, right? Now, sphere formula, it says use an answer to estimate the actual occupied by gas atom. So we know that volume of sphere is 4 by 3 pi r cube. Okay. So we're going to do 4 by 3 pi and 3.2 times 10 raised to minus 11 cube. Can you find the volume of one particle? Okay. And that would be till you are doing this, let me fix the permissions.
4.3 times 10 to the power minus 21.
4.3 times 10 raised to negative 1.
Sir, I got
21.
No, no, sir, sorry,
1.37.
sorry, no. 1.37 times 10 to the power minus 31.
Minus 21 meter cube. Is that clear? Is that
30,
correct?
31.
31.
It's
31.
31 minus 3.
Oh my goodness. That's a big, very small answer. All right, never mind. I don't know, maybe. Okay, so then it says what you're going to do. We got to find the volume. We have the number of particles here. So the total volume of gas would be number of particles times the volume of one particle, right? So we're going to do 1.37 times 10 raised to minus 31 multiplied by 3.0 times 10 raised to 23. Okay, can you find the total volume then? Interesting.
4.1 into 10 raised to minus 8.
Minus 8 meter cube. Okay. All right. So now the question basically starts from the next page. And this says one of the assumptions of kinetic theory gas is related to the volume of atoms. Do you guys know what that assumption is?
Volume is close to negligible.
No, that is not the assumption. Tell me the right one, please.
Volume of atoms is negligible compared to the volume of container.
Volume of atom is negligible to the volume of container. Exactly. So it
Sir,
says
same thing I also told.
no, you said volume is negligible. That's not true. You have to write it full.
Okay, volume of atoms I meant.
Yes, it means you also have to write it. state this assumption, explain whether your answer is consistent. Now, if you look at the answers, right, your answer of one atom is basically this much, right? Which is almost 10 raised to power minus 31, which is much, much, much smaller than 10 raised to minus 8. That is the volume of the container, right? So if I were you, I would write that the assumption is correct in this case as the volume of atoms is very small, or you can write negligible, compared to volume of gas in container. Is that clear? Like that. So you have to make sure that you write that, comparing the two answers. That would give you 2 marks. Okay, done.
Yes, sir.
Okay, well, that's very good. I believe. Oh, yeah. Thank God. Okay. All right. Let me. A2 crash, I want to share anyone with link. It is done already. A2 crash, anyone with link. Okay. And IG crash, anyone with link. Okay. All right. The permissions are there now. Okay. So then
Still can't access.
what?
I can't still access the file.
Which file are you accessing?
Idling gases.
Okay, let's try that at the end of the class. All right, so this is the type of question that I wanted to do. For this one, this is a very simple question, just like we have done so many times. So I'm going to give you this as homework. And obviously, this one is homework as well. Just remember, this is the same thing, the ratio of temperatures. I'm going to add this. T1 over T2 equals to C1 square over C2 square. So that's the thing you want to use right here. And just don't forget that. Anyway. All right. For this type of question, it's something that you need to remember. You're going to do this. So you should write this on your own, this part, but I'm going to do this one. So it says 2 cylinders are connected by a tube of negligible volume, as you can see. And then it says the cylinder A has a constant volume of this, and the cylinder contains a gas pressure this, and temperature. Show that the cylinder A has 0.34 moles. So that's pretty simple.
We'll do P1 V1 divided by T1 is equal to P2 V2 divided by T2.
No, you need to find moles. So you can't do that. You need to do PV equals to nRT. Okay. So the pressure is 3.4 times 10 raised to power 5. The volume is in centimeter cube. So we want to multiply this with -6. And then N we need to find, this is 8.31. And the temperature is already in Kelvin, thanks to them. And what would be N then? I think it should be the same. I'm very confident about that. But you can also check, please.
0.34.
Okay, very cool. So then it says this question, it says cylinder B has a constant volume of 1.6 times 10 raised to power 3 and contains 0.20 moles of gas, where tap T is opened. And the pressure of gas in both cylinders is this. No thermal energy enters, leaves, determine the final temperature of the gas. Now, this is something very, very important, okay? Let me tell you the issue with this sort of question. The issue is that when you basically go back, you realize that here you have 0.34 moles in this one and 0.20 moles in this one. All right. So moles is the real thing that you need to remember, because amount of gas is not going to change. All right. So then the total amount is going to be 0.34 plus 0.20. What is that going to be?
So why
Okay, go on, please.
0.20?
Because it says in B, it has this many moles.
Okay, okay.
Mhm. So then what would be the total moles? Let's go back. It was I think 0.34 plus 0.2. Total moles. Yes. It should be, I think, 0.54. What do you say?
Yes.
Yeah.
Yes.
Then, obviously, when you open this tap, you open it, all this gas is now the cylinder A and cylinder B becomes one whole system. You agree? Now, what it means is now you also need to find the total volume because now the volume is combined. The volume initially was, I think, 2.5 and now it is 1.6 as well. So can we add 2.5 times 10 raised to the 3 plus 1.6 times 10 raised to the 3? All right. So what you get? I think 3.5 and 4.1. है ना? 4.1 times 10 raised to the 3 centimeter cube. Please don't trust my mental calculations. You can please check, okay, as I'm going. It says the pressure, now the new pressure would be this one. So we got the pressure and now we can use PV is equal to what do we need? Temperature, nRT again. So the pressure is 3.9 times 10 raised to 5 times the volume is going to be 4.1 times 10 raised to 3 multiplied by 10 raised to minus 6 because we need to convert it into meter cube. And then it's going to be 0.54 as moles. R is 8.31 and then the temperature. Can you find the temperature, please? I think it should come
356 kelvins.
356 kelvins.
Yeah, 356.
Okay, that's cool. And you can either write 356 or you can write 360 and not more or not less than these. All right. So that's cool. All right. This question is from the next chapter because a lot of questions are mixed. So I'll do this. If you still don't understand why I have added these, because this is just a unique question, please do let me know. Okay, everybody understands this? Wow, you guys are smart. All right. So then,
Unfortunately, yes.
yes, very good. So then, uh-oh, I think I copied the question twice. Oh,
So which
no,
year was that?
no, I think we ended the whole thing. That's why it's copying this. This year, I don't know. Let me check. I need to delete this page. How do I
May June
delete this page?
2013
Delete.
41 variant.
Yeah, something like that. What are you doing? No, I don't want that. I want to delete this page. How do I delete this page? Move page to trash.
Move
Okay.
page to trash.
Yes, thank you. I'm not that dumb. Okay, now I want to move this one to trash as well. Okay, cool. Now we're on to this. This I think is May June 13. Please check the answer as well. So now I have taught you basically from the mark scheme, all right, and the papers, and you should realize that this is all you're gonna get. So I have tried to explain every type of question that you might get, okay, in this chapter, and I believe now you will be able to do all the derivations. You're gonna be able to do everything in this exam. So I'm gonna share this PDF with you now. You guys can go through this, and obviously when you're basically working on it on your own, just submit it and take help. So there are certain questions left. You guys need to complete those. Okay. So I'm gonna print all And I think I started with, when did I start? Somewhere ideal gas here. Okay, 14 till 33. Wait. 14 till, where are you? 14 till 33. Okay. And I'm gonna save it to files first. No, should I? I can do it directly. And then I'm gonna check why your permission I didn't. Well, did you guys get the recording from yesterday? You didn't get the
Sir,
recording?
I was able to access it, but then I woke up today to finish it and then I was not able to. They said access denied.
Yes,
Uh-huh.
that is the one even I was saying. The
Yeah.
Google
Okay.
Drive I'm able to access, but the recording is not accessible.
That's not fair. Okay, so we need to figure out how to make that accessible. And now, wait, create assignment. I don't know where's the. Okay, so this is like ideal gases. Tomorrow, we are gonna do probably temperature.
Wait, so that's it for ideal gases? It's done now?
Yeah, it's done. It's done. And
Okay.
temperature, and probably the temperature will take like 10 minutes of our time. Okay. When we're done with temperature, we will start with, I'm going to upload 2 PDFs. So we're going to start with the thermodynamics. Okay. So for today, I'm going to put the assignment so you guys can complete and submit it. I think this is A2 already. Okay, cool. And here you go. Assignment. And for some reason, I did not upload 2 oscillations. Okay, assignment due date would be till, I think it is fair with you people if you could complete it by Sunday, right? Sunday midnight would be cool. Okay. Sunday midnight oscillation. For some reason, I have put 2 assignments, so I'm going to delete one of them. And you guys can submit your work on that.
So I handed in.
Oh, what? Now both of them are gone. Please hand in again. That's not fair. Okay, so I'm gonna leave it open-ended. Anyway, this one first. Okay, so now let's move on to the issues. So what you cannot access.